Right. Hi. Now it's time to do some refactoring. I guess some cleanup. Maybe we should just move this. I think we can move. Let's see here. Oh well, never mind. I'll do that later. Okay, so let's start here. So what I've been doing lately is adding the bug info. So if I have something like this, we have a bunch of things. We have the globals, we have the structs, we have a few type defs, we have a function, and we compile that, and we're just going to have a look at the bug info from that one, and it is chock full of stuff, and it seems to work. I will do a checkpoint here. So just okay. Let's do it like this. I get a main and just make sure that this doesn't. Oh, something happened here. Did I add something new? LVM code and debug info can't reach that one. Okay, that's special. Okay, so this broke. That's interesting. Debug info. I'll have to fix this first. Okay, so 1 or 2. Some assumption doesn't hold. Okay, so visible extern is unreachable. Okay, I think like the main has this or something. Let's see when I get this visibility. Okay. I think that the visible extern should not behave like that. I think it should just be for the stuff that's actually external and doesn't have anything. So actually I could just do like this: extern equals public, and then we're like done with that. So default is basically nothing, and then we will exit here anyway. So okay. So that worked. Let's compile that, and it's okay. Right, and let's see here. Okay, so I'm just going to commit this. So there's a bunch of stuff here and lots of new things. So debug info. And some bad news is that I used to be on LVM 10 and that worked fine, and then I went to LVM 11 and things started to break. Maybe I did something wrong, but as it changes the API a bit for C. So in order to avoid that, I will keep using LVM 9 for this, at least this time, for now, right now, for this thing. So let's talk about refactoring. You always have to, in my opinion, have to work a bit and then clean up and work and clean up. It's like if you're cleaning up a house, right? Or you're building something new in your house. You will, have all these tools spread out and build something, and then you have to clean it up after you're done, right? Because you might have scaffolding, put up ladders or whatever, and it's also like that. You just do it the straightforward way when you work normally, but then you have to go through and just clean it up, make it look better. And I actually gone through doing that. Like for example, I did this. I think the day before yesterday or so. I went through these. These were used to be like sub overflow, and now it's like consistently intrinsic ID. And the same thing here is like the attribute first. And the reason why I do this is like, okay, now if I code complete on this, I know it's like going to start to attribute something. So, and also lookups and whatever. So that's fine. And I started my change from using gen context for everything. So now you see like everything here is LVM something. And we have like the LVM value, like the B value methods here. So B is just backend something, right? And then I have like, okay, this one is here. It's probably not going to be used much, I think. It's like store value. I want to change. I want to wait to do this until it's. I decide what it should be. And then we have everything here just alphabetically sorted, more or less, right? We have this gen context emit alka, should be like LVM emit alka, right? So we change that. There is a then we have a few get types here, and there still is like emit ones, and this one should be like emit and copy to Jekyll, right? So now it's at the right position here. We have these debug ones, so LVM debug scope push, and those should be like with LVM debug stuff. But oh no, sorry, that's debug emit debug. So we have a few debug things here somewhere. We have store. We have these that are not yet moved. We have this emit load that maybe I don't know how much I use this now, because we're going to do that differently. There's some here declaref and getting the LVM value out of that. So and then here's a store, and again this probably shouldn't be used anymore, so that's why it's like here. We have the emit cost thing, and it should, I don't know, it should probably like BSB and LVM, right? LVM emit cost, and then we can move it up here. Emit is emit C cost. You don't need to put them like together like this. It's just that it happens to be like fairly simple to find this way. So like you can group them like this, and that makes it easy to find it later on. Okay, and that's why I also like taking these static inline things and try to declare them further up, so they're in like in one place. Okay, so we have a few of these. Maybe I should do like, okay, LVM emit store So we have that one there already. Okay, so sorry, that was wrong. Okay, so because these are already up there, here's this bit cost. So it should be like LVM bit cost, and then maybe I'm using it up here. Emit bit cost. Right there. And this one is like still returning an LVM value ref, and that is something I'm like working towards removing. Here's the constant. That was 0. That one is good. That was very useful helper method actually. We put them with the gets, right? Because you want the zeros so often. Just a 0 of something. And here is the pointer type. You want this one up here as well. Get type, get 0 is there, right? Okay, then we have a lot of this is actually junk. I don't think we use this one. So let's just remove this. Or wait, this is something we need later on. Okay, so now this codegen is sort of cleaned up here. It used to be much worse. We can see that some things here are not in use, like this one. Like what did I use this one for? This is nothing. Let's destroy that one, right? And we have these. These are actually things that should be in there. We should add this attribute op none to certain functions if you want to, like if you require op none on it. So that's something, and add string is maybe something for later. Let's see here, and this one maybe I want that one later on. Let's see here. So it's get to struct. I don't use that. Then it has to go. Okay. And get queries type will be like LVM get queries type, and it's a get. Like roughly. Okay. The debug one doesn't have to be exactly here, but mostly. Okay, and this one is up there, right? Okay, and we have this one, that one, right? So that one started to look okay. So we go to LVM. Like we have this internal thing for everything. It's compiler internal. It also has a bunch of these. Whoa, there's a lot of jello there. So here is some stuff that I haven't used yet. Some will never be used, but I am not super sure that they won't get used. So I'm sort of waiting. And here we see it's sort of organized already, right? We have the expert, that one should probably go with experts, right? But here we have the decal, and then we have the expert. So expert is constant eval. We have to have that one down here. And now we have a bunch of token stuff and SEMA. So we have a SEMA somewhere here. Expression something. Yeah, here we have a bunch of them. So those should go down to SEMA. Let's see here. SEMA analyze expression. This one is a special one that I needed. For some reason to go in there. And then we have all these, the token ones, the type ones. Here is the type info, the type kind. Here is one, and that should go in times. Reduce something. So reduce from expr. And then we have that. Those are already prototype higher up. So type will truncate. Okay. Do we have a so type convert? No, convert. So type convert. I don't know. I guess that's fair. Okay. So we have this one, that one is done, that one is done, that is moved. And then we have these. Type is promotable integer. Then we'll move this one down here. No, it takes some types. Okay. Type is. There it is. Okay. It's good. I'm just going to say that one. Okay. There are still complaints like the max errors. I don't use that one. So let's remove the max flags. I didn't use that one. Lexer VM size. I don't know. If it's good, I can add it later. Apparently I don't use this one anymore, and it has to go as well. Then it has some to do here for the vectors, but now I have a vector actually. It's unclear if it'll look like this because doing multidimensional might be different, but I don't know. So it's here. So this one is fine. So this one is like type. I don't know. Here's like a question: will it look like this, or will it look like maybe like this? Still, and something. Okay. And here there's nothing that I need. Oh, an alias. I haven't done the aliases yet, and I don't wonder about this one. So I am going to maybe remove that one. Yeah, I don't think I need it. Okay, and in macrocall, I already handled that. Built-in may negate. This was an old one, I think. Okay, so we remove that as well. Let's see here. Here's a few of those. These are like invalid keys. Okay, whatever it's complaints. Yeah, because this is a function, right? Well, I'll decide later on if I want to change that or not. Okay, so that's actually mostly cleaned up now. Let's see what we have for internal. We have a few more. So we have the parser internal, but that one hasn't been changed for in a long time, right? Sema internal, okay, that one is almost not doing anything. So there is not much. I mean, the big thing that you share a lot of things is like with the codegen, because the codegen is split into several pieces here, and I'm just going to like Someone says, found it interesting to hear that the Circle guy implemented the entire Itanium API in basically a C++ compiler. Yeah, that was super impressive. And he was like saying, I was like, okay, I've done, the API, C API is like, it's been a hell of a ride, trying to figure out from Clang what it's supposed to be. Like even in the process of doing so, finding stuff that's probably bugs, and I managed to at least find one bug on the Win64 API, the implementation in Clang, and I'm still not sure if I actually triggered the right one, and I don't know. I don't have quite have the LVM up, and I haven't really run make on it. I just read the code. I never run it, but I don't even know if I managed to trigger that exact bug or if something else that I found, because that code is super gnarly. I mean, everything in Clang is, but in particular, like looking through that's pretty. You have to know so much about how things work with Clang and with LVM to make sense out of that code. But that was not like if you then when you go to the C++ part, that's even worse. So because then you have to also understand like how does like Clang implement vtables, exceptions, all of that. Like if you don't know that, it's going to be almost impossible to read that code, and that's why it's so hard. It's so darn hard. Okay, so now cleaned up. That was just cleaning, the headers. But it's surprisingly important to have it easy to navigate, right? So the next thing is like because I was doing the debugging for right, so I need to sort of have a look and see if should I be doing anything else. And let's see here. So this is, I don't know if this is correct. When you do it seems like every time you do something that could contain something else, you should use the you create a temporary, and then you can use that one instead of going deeper and trying to create a like you can get circular references when you go deeper into trying to generate the debug types. So you have to make this placeholder, and then you have to do a swap. So here I'm creating the actual struct type and doing the swap, and I have something somewhere here that is actually doing the forward thing. But now that I'm thinking about this, is this going to work? Yeah, it's going to work, because you already defined the struct, so when a member tries to refer to this one, it's going to be fine. Yeah, just it's easy to get turn around. So okay, let's see here. So sorry about that. This is the global. I have a bunch of those. Let's see why okay, so this one is called externally. Most of these are actually just the ones that are creating types that aren't. And here I have some debug this forward comp, so make now static, maybe static inline even, because that's just a single call. Oh no, it won't be possible to do that because there's a counter here. I can put that a counter right here. So counter. You say like, okay, every rename all the code is just yes, thank you. So when you create a temporary placeholder thing, it has to have a unique ID. So here, and it takes the ID counter, right? And then we can put it up here, so it's like a bit cleaner to say like, okay, these are the ones we actually have static to our function, and we can find them as well. Okay, and do right, so it was static inline, right? I know that even if you do this, it usually usually when you do this as C++, C compilers won't care. So the inline will be inlined if it feels like it. Hang on, this is the debug, blah blah blah. Here it's up here, yeah. It's static inline. This is a pretty worthless thing. Do the inline. Okay, the scopes. And here's declaring a function, a local variable, a debug parameter into the function. Here's emitting the debug locations, and then the forward thing. All right, I think I'm just going to add something here. So, oops. Save struct like, okay, because that's a word I like to use. And here we should handle the recursive vectors. Is that possible? Yes, you can have a vector of a vector, so that should be possible later on. But that is like I was going to do this, to do handle recursive. Right, just break that. Okay, so here's another fixed recursive, and it's the function type. The function type is actually not implemented yet, which I discovered somewhat to my surprise. But, okay, this is not nice. Well, let's do it like this. Handle to do handle recursive vector type. So it's going to print that out. This is a new trick I tried, because these are like, no, I don't read those. Like you have a bunch of them, but if you do like this, to do support recursive function types. So basically you could say, okay, let's type of a function that takes a function to itself, like the itself as the parameter, right? So you cannot have an int. Can you really have that? Yeah, you can have a function that takes like takes a function that takes a function. Is that possible? Like I have an int, and it takes a int foo will take a function to a function that takes a no, that's not possible to do recursive, right? Yes, think about that. Yeah. Hi. By the way. So okay, I don't think I need that. I don't think you need to handle that recursive. Okay, and here's the debug code, and then here's just wait. This isn't needed anymore. Okay, so you're just going to take this and then make the scope, like all types should be generated in the outer scope, right? So if I have something, it's always in the outer scope, even though we might be starting like we find a type and then we do that on command, so we can discover a new type as we are compiling something, but that is completely unrelated to this one that is like the scopes here, the bug scopes. So completely don't mess with that. Okay, so that's correct now. Okay, and now let's just compile just in case we did something wrong. Here we did. So we have something in macro 0. Okay, we don't need that, but we didn't need that, but now we're done. So okay, and okay, so there we are. Still working. So now I'm just going to post cleanup. Now I want to see if I can, like, if I feel this is sufficiently stable that I should push this live. So okay, we get something that is not working. That's good. Or it's not that good that it didn't work, but there is something here. And that is somewhat surprising. Okay, because I didn't think I was doing anything to any other code that could break, but apparently I did. So this is the code that breaks. We throw it in here in my test thing, debug stuff, right? And let's run that. See where it fails. That looked a bit like okay. So we have a unbalanced pop and push here of this one, and this one enum should not be using this at all. So maybe I should like just look for that. Okay, now we go to just any debug thing, and we have like this current scope. What is that? Where is it used? It should not be used anywhere except for that place. That's good. Okay, and then we have this push thing. So do we push it somewhere? Only together with the compound. That's good. And do we pop it somewhere? Debug pop. Debug scope push. We have like what? Okay, so this is debug. This is okay. So we have like the lexical scope and we have the scope. Okay, maybe these should all move. Oh, sorry. Yeah, I have to. Hang on. All right, sorry about that, kids. All right, so we have this go push and pull and pop. So here it's not being used incorrectly, and here it's not being used incorrectly. Good. Then let's run this again. I think it's more likely to work now. Run through. Oh no, invalid base type. This is super interesting. I am getting some things that I didn't get before, and I'm super happy. So I love having tests, right? You know, when you have them, and then you can like start figuring things out. So now there's the incorrect base type for my enumeration, I think. And let's see here. So so an enumeration. Let's see here, the bug type, the bug info, and I have an enumeration enum type, and then usually I would just I would use this one. Oh, that's correct. But we when we do this, let's see here, when to put the here's the type alignment, the type size. So where's the elements, and oops, what is this? What? Okay, so the reason here is because when I put in the type get the debug type, so I didn't I sent the scope instead. So the enum real type is that one, right? The canonical one doesn't make sense. Okay, so what is wrong with that? Now it's very happy. Okay, we just done this test again. Oh, something else breaks. Right. Here's something, pointer access. Okay. Let's see why that breaks. So this might be something, again, since this is just the debug stuff, so the only thing that could be breaking was this, the super simple debug code that I have is still like sufficient to there are things that I didn't exercise. So okay, here we have something else. So we do a struct type, and then we want to get the name, and the name doesn't exist because it's 0, right? So that is a possibility. I didn't think about that. So so it's basically something like that, because we have like anonymous members. I don't know if this is correct, but this is the way. Let me see. I'm just going to consult Godbolt, how it looks like. So hang on. I'm just going to make a struct foo, and it contains a struct that has an int, and then we have an int b, and then we can use that one somewhere. Struct foo. Sorry, this is on another screen, so I'm just going to see what that looks like. Does it do something special for that? Okay, so we have member, and the member has not a name. It just doesn't have a name, that is all. Let's see what this one we produce here. So with the bug stuff, blah blah blah, we have a file. I put somewhere test fragments here. Okay, so how does that look like? So we have that one, we have the okay, how does this code look? So we have the struct here, we have the RNS, right? So this is our anonymous stuff. So we have a structure which is, it's called extra simple. Extra simple has a bunch of members, and we have a member here, and then a member here, and then we have, there is something called a non, right? And a non contains these, but actually this is incorrect, I think, because this should be, here's a union type, right? Okay, so it's still debug and non, okay, because this is incorrect. So sometimes we will have a name, get a member, and the type will be that of a, like here's a struct like type, we're going to provide the name and the external name, but if the name is, do we have this? I think it's going to have to go through it there. So in this case, the name is extra simple, that's fine. We go here again, and now the name is C, and that's okay. We go again, and now the name is a non for this type. But it's actually, let's go back here. So the decal doesn't have a name. It have this external name. Okay, so this is important. I have to, if the decal doesn't have a name, maybe further down actually. So if the decal doesn't have a name, right, so if the decal doesn't have a name, otherwise it's going to be that one. If type decal doesn't have a name, if it has a name, it's that, otherwise this it's 0. And then the external name, if this again, if the name exists, then we have that one, otherwise we have this. Again with this, if it's a name, then we want to have something, otherwise we just want to take 0. And then we do the same things with the structs. So if it has a name, if it has an let's here, so get the debug struct. And here, so if the decal name, if it has a name, then we do the external name, otherwise we do an empty string. And then we do the maybe if the external name, so if this one is 0, you can do something special. So this one, if the If external name len, then we do name. Otherwise we do this. And the same thing, if it's an external name, then we'll do this, otherwise we do 0. Now let's debug this. Okay. Let's see how that looks like. Now in this case we have again the members. Here is a member and it doesn't have a name. And that's exactly what we want, right? And that one, but that one has a base type which is 22. And that one has elements 23, which are these two. So now that looks okay, the way I would expect it to. And let's see, it has scope and it has a base type 23 here. And that's a unique type here, and it has nothing. It has this distinct though. I don't get the distinct stuff. I am not sure why, so I should probably have a look at that. Like there are the flags, so maybe there's something distinct something. So let's see here. Okay, that is something for later, I guess. Now let's just see that this compiles correctly. So running again with everything on, and boom, it passes. Okay, then we're pretty much, so let's do the commit for this one as well. And now we are taking this and let's do a rebase on this whole thing. We're going to rebase it on master, and then we're just going to, you know, squash everything together. Squash. And then we have like, okay, this macro param foo type foo, okay, and then we have the API x86 arc, that's the name, right? And x64 and win64. And why is it called win86? Stupid me. Okay. And then I have like all of these things. B value refactoring, and then debug info added. Okay, and okay, just like that. So let's rebase on that first, and then we will fix this. This is not win86, win64. 64 refactor, and then we do another okay. Show difference. See. Okay, let's just try to do this. What happened? Okay, I did something, compiled something else. Okay, let's save that one as well. Git rebase. This is my my way of fixing doing rebases, which is something I don't recommend people. Maybe it's I just try to do it as simple as I can. Okay, so now, and the way I do it now is like I never push something rebase done to something that isn't rebase. So I'm going to remove the old, and then I'm going to push this on top, because now there's just new and clean stuff. And I think there were some errors that I need to fix. I seem to remember that didn't want to accept the old things I did for dev, so right now it's just going to run some actions. And let me just see why it failed before. So okay, check file failure on line 1. Just going to see what happens. So the build, hang on, the build failed because, okay, so there's a fall through on types in the types file. So types 3, no, types 3 something. So here there's the fall through. It needs to be explicit. So let's just add that one. Just amend this commit. The recent one was okay, whatever. Like this. Now we still don't have a K tab, so we push this. Push. Okay, that was bad. Let's just do something, and then maybe I can get my all commit messages back somehow. No. What did I write? Let's see here. Sorry about this boring stuff. I'm just going to look at the dev branch. Oh, did I kill that already? Okay, I need to be more careful. All right, so I'm just going to guess rebase this one. Commit. Git rebase. Let's do a reward and to add macros. Macro commands this foo, and foo. ABI. C ABI compatibility arc64 win64 x86 x64 added debug info. Yeah, pretty much that. Now again, let's push. And so C3 as programming language for anyone watching. Just saw a question. All right, almost done here. It's already been an hour. I had more issues than I hoped for, I guess. Next thing is trying to add a bit of Oh, it broke this one as well. So okay, let's see what didn't work. Oh, the parenthesis. Okay, there is some error. So type is union struct. So I have a different set of type. Oh, so just line 226. 226 as this one, and it. No, this one, and it's a good thing to worry about for the compiler. I don't know why it worked like that. Should be like this, right? So, oh, I don't know. It's going to be pretty fast anyway. So now there's not a problem. So let's just maybe I just push this right. So fix to types. See, commit, and I push this one. I can always rebase later on. Push, and now there's going to be another build action, and I guess I'm. For now, I'm just going to, I guess, end this here. This is not going to be very interesting to just wait for me to continue doing this. Are there any questions? Or like something you want to know about? Right now, I can talk about that. I can talk about anything you feel like. Let's see here. Still stuff. So things are not working right now, but or it's sorry, things are working, but I am having errors when I do the continuous integration because it wants me to be a bit more careful about things. And let's see here. So it was the cogen. And actually, these are good things to be pedantic about, so I should probably add them. So let's see what it complains about. So it says this may fall through. So designated thing, of course, that should be a return. So I obviously don't have a test case for this. You see here, I think I have a few tests there. Yeah, so this was an actual bug. I know that this is sort of, right now, this is something I want to continue with the subscript and so on. And I've done a lot of improvements to this code, and it looks just like what Clang does. But there is more. Like currently you can't take like let's say you define a struct, a temporary, right, and with constants, and then you should be able to manipulate that one during compile time. Question, this is a programming language that I'm making. And right now I'm just fixing some bugs before I commit all this. And there's obviously another one, again, context middle length. Okay. There's another fall through. This one. Okay. fall through bugs can be really hard to spot sometimes. When you were starting to run the code, because sometimes the fall through will not do anything, and sometimes it will. And when it does some things, it can do non-obvious things. So 3 doesn't have fall through, but now there's still an error here, so let me just fix that one as well. Too many things that didn't get caught by my, let's see, what? I think this one just broke for no particular reason. When I did the build, what happened? The process exited, okay. Rerun. Oh, I just thought of something. I should be updating the front page of what is done as well. So while we're waiting, let's see what we have here in terms of what is done. Okay, we have this is done, this is done. Let's see, for each, no, those are not done yet. CT type constants, maybe they are done, not. This is done now. Subarray initializers, I am not sure that I did that. These are not done, I think. In progress. So I guess that's it. It doesn't seem much, but I should actually add like debug info press. Okay. Vectors. CMD vectors. And we should add like complex types. Okay. Did it work? No, it's still, I think it's still broke. But okay, so this one worked. And then okay, we had an error here. ABI in the ABI. Oh, sorry, symbols. ABI is indirect. Okay, so it's here. And then we have, like, is there another one? 1, 2, 3, 4, 5. 2, 3, 4, 5. And then it should be like unreachable for the rest of them. So let's see here. So and I'll push that one as well. So I'm waiting for that. More questions. So LVM based, yes. And what should I say more? If there's a question about LVM, I'm using the C API, by the way. C API, sorry, LVM C API, because first of all, I'm just writing my compiler in C anyway, but second, it's more convenient to use the C API. It's much nicer. All right, let's see. It still failed. Let's see why. And the run failed again, and this time it failed expanded size. So I think probably expanded size there. This is exhaustive, I think, but so it should be unreachable at the end. So like that, but I didn't add the unreachable. There might be others like that. Let me see here. No, that's the only thing. Again, there is an action CIA. So this is GCC has different defaults, and I'm just saying like do the normal checks that you do, and client does different checks than GCC. And let's see if it breaks the building, and there it breaks x86 classify argument. Okay. And what happens then? So here this should be unreachable because that's taking everything. So there is some stuff I need to do the vector call, the last part of the vector calls for x86, but I don't know if it's worth it, you know. How many are using, 32-bit x86 right now, maybe for embedded or something? I don't, but they won't be using vector call anyway. So should I implement that or not? I don't know. Okay, see if I got something. I don't remember if I pushed or not. I didn't. And maybe I should, put something here in the information, like taking a link or something. Hang on, I'm just going to put the link to that in the title stuff. Wait, maybe you can see that. And still waiting for a green light on my check-in, and I think that still didn't work. Yeah. So we have another one in the there we go. We have these are the only classes, so it's unreachable, but I didn't annotate that. 387. Again, these are, it's, oh, ooh, bad, very bad. was bad. That's a really bad fall through. God. Okay. I am a bit worried that I will start using C3 and not get used to having this, adding the breaks. It is a thing that, you know, it really often happens. So that you go between languages and then forget to add something that's in one or the other. All right, let's see here. Compiling, 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 and do we get to the linking? It actually built, so it's fun. I'm not running any tests right now on the like no reason why I should have all these, so I just squash those, and then I don't need to squash that one, so squish, then okay, let's remove those. Now we can rebase. We can get everything super clean and nice and not have all these mistakes. It's not that I'm like proud trying to remove like mistakes, but when you read code, you don't really want to read the mistakes, because essentially what you want to see what happened between check-ins. So that's what you want to. You really want just the relevant stuff. So it's a pretty big commit that I'm doing now. To like going to put in master now, because of all the I'm like added macros and CABI and doing a lot of cleanup and adding this be value thing, but it wasn't, the code wasn't sufficiently stable for me to want to push it to master. And that's like the thing is, I want every check-in to be stable. So now I am pushing this, like adding this to master. So I'm going to merge that now. Right. And then I will actually delete the branch. Alright, so now we still just have one branch, the master one, and it has one huge commit, and you are welcome to have a look at that. Like there are a lot of things added, but it should be fairly easy to see what we got new, at least in some files. So, oh, it failed to run some things. Let me just have a look at why master suddenly failed to. No, it's okay. All right, thanks for watching. There is a new version of master then, so I will just do a pull here and we'll see getting that, and then I will, oops, that's interesting. I must have done some changes in master. So let's close that. Let's just kill that one or something. Just want to roll that one back. That one. Poetry base. Okay. It's just take another one, and then I'm going to kill this, copy, and then I'm going to see what the commits were that I'm now losing. Oh, and then I'm going to check out the master, okay, and then I'm going to kill the dev one, and then now I have master and just making sure that it looks okay. Yeah, it does. Okay. Job here is done for now, but next up I will be working on something that's completely like I haven't done anything in a long time on the main thing here, right? Because we have a bunch of them to do. I think that maybe we should start doing something else, which is like looking at when we compile, we are going to take some of the build options that we handle somewhere that's here. So here's where we would do that, and we might make take different targets and so on. But I want to change that. So I don't know how much I did. So this is not so much language development, but interface development for the compiler itself. Okay, thanks for watching.